those of messages are the ones that can really show me that we are moving together. So when you record the mass to no decimal place, we give you also no mark. It can be 1 or 2 depending on the weighing scale you're using. But I've told you that our scales always go to 1 decimal place. Chantal, you're putting up your hand. Hey, someone is asking, how about 3.0 grams? But that is 1 decimal place already. You are right, depending on the scale you are using. This is half a mark. I'm saying no decimal place. This is 1 decimal place. The moment you record 3, 8, something like that, that is a very good 0. It is not mandatory that it is 1 dp. I've said depending on the scale you are using. I don't know the scales at our different schools. Me with my students, we record it to 1 decimal place because the weighing scale we use records as the calibration to 1 decimal place. Okay. Then the other thing on weighing, on recording values of mass, another thing that I can talk about, the mass of the beaker should have been correctly subtracted from the mass of the beaker plus the solid sample to give the mass of the solid sample. If you are to get the mass of the solid sample, of course, you have to put into consideration of the other empty substance where that mass was, where you added it. In other words, in case the difference between the mass of empty beaker and that of the beaker, that is if at all you weigh using, you put an empty beaker to weigh that substance. Some use filter papers. So to get the mass of the substance, of course, you have to subtract very well. It all depends on the procedure given. So I may not anticipate quite much clearly here on what is likely to happen. Okay, so I may not talk about it much. Maybe when we start doing when we start one of the numbers, when we do one of the examples, I will elaborate much more about those masses. Okay, now, of course, the mass of the empty beaker should always be less than the one of the beaker plus the solid sample. You can't get a solid sample, you put it in a beaker, and then you tell me that a solid sample with a beaker, they have lower mass than the mass of the beaker, rather they have a lower mass than when the beaker was empty. So sometimes students want to write things because they are chasing time. And we also give marks because we are chasing time. So you have to be accurately sure of the apparatuses you are using. When we go to one of the examples, I'll give you the clear light about masses, okay? Then volume of the pipette. When you're recording volume of the pipette, it must be 1 decimal place. However, in O level, UNEB is not like a homestead. The students writes 25.0, 20.0, 10.0. These are all pipettes. This student is marked very well. A student who says 25.00 and the eye is crossed and is marked. But why? We prefer 1 decimal place with a pipette. 1 decimal place with a pipette. When you're filling the table of results, each value must be recorded to 2 decimal places. When you're in a table, each value is recorded to 2 decimal places. And the second decimal place must be a 0. You can record like 20.20. The last one must be a 0. You find some stubborn students say 20.11. Hey, We welcome you home very, very, very well. So we are saying that the values in the table must be recorded to 2 decimal places with the last point recorded as a 0. Hope I'm very clear. So you can record anything. You can record 20.30, you can record 20.50, you can record 19.60, something like that. Yes, Irene.
Okay. Teacher, what if it's recurring 20.111? That means you round off.
Where? Because the values in the table are the values of the bullet. If this is the calibration, if this is 20, there are 10 divisions, whereby each division is standing for 111. So if you have 20, maybe it is on the 4th, just say 20.4, where the meniscus is 20.40. Are you getting my point? We are on recording in the table. Are you getting it, Irene? 20.25, those were ancient values, but we can mark this.
Yes,
if it is a 20.25, it can be marked. It is marked. That is why I was going. That is where I was going. So we are saying, I'm still telling you about the table. Record to 2 decimal places with the last decimal place being a 0 or a 5. That is different, or the meniscus is within between. If the meniscus is within between, that is when you can record a 5, like 20.25. But those are rare cases. Okay. The second, it can be a 5 if the reading is exactly between the 2 values. Okay. Say if the reading is between 22.30 and 22.40. Here one can say that the accurate reading is 22.35 if it is in between these. Am I clear? If it is in between, yes, it can be recorded as 0.5. Which means that it is safer to end with 0, right? However, do the practical. What the practical gives you is what you record. But to me, it is safer to end with a 0. You can rarely and barely make mistakes, and you can maintain the accuracy very well when you had ended with a 0. Okay. The value, rather the initial bullet reading, may be either the same or different, but we don't like it being the same because we are asking ourselves, aren't your solutions reducing? Because your neighbor specification is always clear. People who are not muted, I'm going to remove you from the class. Very clearly. Very clear. I'm going to remove you. So I'm saying that the starting point, the starting bullet reading can be the same. One can say maybe 0.00, but we are wondering, aren't your solutions reducing? So one can start like from 0.00. I can go now to like 10 or 5.00, and then my other starting point can be 10.00. These ones can be my initial bullet readings. But when you make it 0.00, I start wondering, this student was given maybe 100 cubic centimeters. But according to what is getting in the table, the 100 cubic centimeters is already used up. So where did this student get other solutions? This school must have cheated for these students. Maybe they give them tighter values. And that is how schools' results get withheld. Mostly it happens with the practicals. You find the whole school is having one similar thing, but which is wrong. In practical, it is funny. But even practical was telling me that there is a school which had wrong same answer. the whole student. So what do? You hold the results. They copied wrongly. They copied wrongly and wrong thing moreover. Okay, so of course, to get the tighter value, as we are told in O level, you subtract the final. To get the final burette, rather to get the tighter value, you get the final burette reading minus the initial burette reading. But you understand me very well. I've said that they can be the same or different. When you start with 0, 0, 0, 0 as initials, we are asking ourselves, and your solution is reducing and your solution is changing. So every time you are feeding it to 0. So we don't like this. However, nobody will penalize you for it. But we don't like starting from 0, 0. Here you are trying to tell me that you've not done the practical. You have not done the practical. You will not tell me that all the things, all the reagents they gave you were enough that you could keep feeding you back to 0, to 0, to 0. There is a specific amount they give you. Never be practically misunderstood. Okay? Try to do all your best to avoid being practically misunderstood. The first value can start from 0.00. Then my other initial reading can be 0.00 still, but another one can be like 15 or 10.00. So you try to be practical, tend to be too practical. Then the final bullet reading, like what happened last year, that's why the part B of the question was discarded. They didn't mark it. The final bullet reading should not exceed 50 because the bullet stops at 50. So if you get 70, like last year, since we are getting 70.00, it means that there was a problem. So you shouldn't get the value exceeding the bullet. If you have pipetted 25, it must, if you have pipetted 25 cubic centimeters, it must react against the volume in the bullet in the limits of 50 cubic centimeters. If the specification was very clear, last year's Titan value was supposed to end in the 40s there, at least. But since we are recording 119, and still when they have not gotten them, one does the traits and things get done and just records the value. So to be practical, it will be stopped. It shouldn't go beyond 50 because this is the biggest volume a bullet can measure. Okay. Now, the 3 tighter values after subtracting, I'm assuming that my table is like this. I've started from 0.00, 0.00, 10.00. I've started like that. Then maybe my final is 25.30. My other one here is 25. Of course, here it will be the bullet reading will be 25.30 after subtracting. If here I go to 25.10, here when I subtract to be 25.10. And if here I went to 35.00, it will keep at 25.00. We are saying that this bullet reading, the tighter values, should never be the same. All the 3, 2 can be the same. 2 can be the same. 2 can be the same. Someone was asking, that person inboxed me that their teacher was like, the first value is taken to be inaccurate, and therefore it cannot be used to select the values when you're taking the tighter average. No. Even this one can be inaccurate, but this one and this one can be accurate, depending. So, but according to the accuracy of the results, of course, we are taking the ones whose error is plus or minus 0.1. Even if the one is pretending to fail, at least you shouldn't fail to record very accurately in your table. You shouldn't fail to record accurately in your table. At least one value should be different from the rest. Okay. I can record my averages here can be 25.30, 25.20, and 25.30. This is okay. Here you can take this or you can take this. Because the accuracy is okay. The error plus or minus 0.1. You take the ones whose error is under this or which are the same. But here, if I were you, I would pick these. Okay, so it is not guaranteed anywhere that you must take the last two. The last two. It is not written anywhere. Then let me show you how we mark this thing. How they mark this thing. I mark students at school, but I don't mark practical in able. But the standard of the marking this thing, okay? When you do the practical, your teachers do and submit also. However, it so happens that also teachers can be inaccurate. So a mark, the average title of a teacher may not be minded on these days to give you a mark. Sometimes they compare the whole center, what you've got, what are other students' values, the whole center. There is a year when in some school I was told the average students were around 25.4, 25.5 hours, but the teacher got 28.20. So if we are to mind about this teacher's mark, then there is nobody who could get the marks. Now, the average value should be very, very, very well calculated. Before this table is marked, the student's data values are expected to deviate by plus or minus 0.50 cubic centimeters from the average submitted by the teacher. That was the original consideration. Even they still mind about it. They still mind about it. For instance, if the teacher's volume for the table is 24.50, then the acceptable range of the students would be in this line of 24.50 up to, okay, you will actually it is for the table we add or subtract 0. We add or subtract 5, not 0.5. The average is where we subtract 0.5. So it means that if the teacher had this, a student is supposed to have from 24 up to 29.50, or from 19.50, because you will subtract or add. So from 19.50 up to 29.50. That is the deal with the table. That is the deal with the table. The deal with the table is open. Many students get the answer. Do you record the average 2 decimal places? Yes. Anything you've gotten from the table, do to 2 decimal places. So here, the accuracy, they mind about the accuracy based on the value someone has added. If the teacher's value was 24.0, it means all students who have recorded from 19.00 up to 29.00, all of them, their table will be correct. Table, not average, table. They'll give you all marks for the table, all of them. But when it comes to average now, the accuracy reduces to plus or minus 0.5. 0.5. And how do we come to this? How do we come to this? Excuse, can I carry out one practical, then get other answers by calculator? Does the calculator do the practical? Your hands are the ones which do the practical, not the calculator. That one, even you can do it, but you should never mention it that you have done it. Okay? You shouldn't talk about it. You can do it. You can use that skill as your teacher told you, but it is not practical. You should never say that I got the other values by a calculator. No. For us, we need the accuracy. If you were told to do to use the calculator, I'm assuming that I have 0.00. Maybe here I got 23.40. It means that my value here will be 23.40. If I want to keep in this range, even I can first fill here. Bright students first fill here. But this is not practical. Maybe you have been caught up by time or something like that. I can fill 24.20, 24.20, something like this. Then here maybe I can make my starting point to be, remember me, I'm interested in these values. So meaning here I can say maybe 5.00, 10.00. Then I add to get this. But that one, nobody should know about what you've done. Nobody should know about what you've done. That is your skill maybe that makes you pass score. But it may not render that you are practically accurate. The average may be cancelled. Now, let me take you to choosing values for calculating the average data. Now, when you're choosing values, there should be consistency in at least 2 data values, which are supposed to be used in calculating the average. These data values should be obtained or chosen, or should be those closest to each other, that is, those with the smallest deviation. We shall not mind whether it is the first one and the last one. We shall not mind about whether it is or what. No. Are they accurate? Are they closer to each other? Hope I'm clear. Now, the consistency that we try to look at are those values whose error is 0.10 cubic centimeters, 0.00, those ones which are the same. So you can pick values which are the same. You can pick values which are the same, or the ones which are deviating by 0.1. For example, I may have 23.40, 24.20, or 24.20, or then 24.30. Here you can pick this, or one can pick this, because they are all deviating by 0.1. All right. Now, that pair is chosen according to this consistency. You should get those values which are consistent. Now, a student who records the averages like this, 23, rather the final values as 23.40, 24 maybe 0.90, and then takes us to 25 point. This one has not done a practical. You get a 0. You have not done a practical. Better lie if you can't. If you have this in mind, you can better lie and get the marks of the table, and you lose the one of the average. Remember, there is always 2 tables in your practical. Each average takes 2.5. So by losing 5 marks because of average, still it means a lot. It can affect you a lot. So better try do the practical, because I'm going to show you what you do to get marks on the average. Now, choosing the average data, then after getting the data values, then the method should be very, 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 very much shown. You should be sure how you've gotten maybe 24.40 plus 24.40 out of 2 to give you 40, is it 48.80 out of 2, which gives 24.40 cubic centimeters. This student deserves, if this value, if the teacher submitted 24.50, this student gets all the marks, because this student, his answer is deviating from the one of the teacher by only 0.5, rather by only 0.1. So if your answer and the one of the teacher are relating by plus or minus 0.1, you get all that 2.5 marks. You get all that 2.5 marks. If your answer, here you get 2.5 marks. If your answer deviates from the one of the teacher by plus or minus 0.2, you get 2 marks, the half goes. If your answer deviates from the one of the teacher by 0.3, plus or minus 0.3, that is a student, if the teacher's value was this, and for him he gets 24.20 or 24.80. These are the people who have deviated by 0.3, either by adding it or by decreasing it, by reducing it from the one of the teacher. You get 1.5. If you deviate by 0.4 plus or minus 0.4, you get only 1 mark. If you deviate by 0.5, that is students who get 24.00 or 25.00. That student gets a half a mark. If your error from the value of the teacher goes beyond 0.5, on the average, you get 0.0. As simple as that. So is it a must that the average volume to be 18.5 cubic centimeters, e.g.? I'm not getting your question. I said that the average volume, go in your table, pick the 2 values which you stated to calculate the average, add them, divide by 2. What you get, record that. There is no any must. Otherwise, you can divide by 2. You can have in your table, you can pick like 24 point, you can pick like 24 point, you can pick like 25.10 and 25 maybe 0.00, depending on the values you have, like this. You find after getting the average of these, you're getting 25.05 cubic centimeters. This is okay. You're going to get the marks. So it depends on the values you have selected. According to values you've gotten, marks will be given to you. Hope I'm clear. If I'm clear with you so far, type yes. If I'm clear, type yes, because after getting the average now, it means we go to how to calculate. So there is no way how I will teach you to be accurate. You be accurate practically. The first 2 can show you that you are accurate. Okay. The first 2 titles can show you that you're very accurate or not. If you are told that you cannot use a calculator to be accurate, use a calculator to pass the table, but not to pass the average. The average needs you to do the practical and you get the correct values. By doing the practical, you can revise the range and you see that you can get the marks. So now, from there, when you're calculating, all calculations must be based on the mole concept and should be done from first principles other than the formulas. Students who use formulas are not marked wrong, but you get few marks. They will mark you, but you get few marks. So you have to do from first principles. So a student that uses mathematical formulae but doesn't use first principles, they earn slightly fewer marks on a particular, depending on that question. So during a particular question also, during a particular question while calculating, you should avoid rounding off at very early stages of the calculation. Rounding off is recommended at the final stage or the last stage. I want to do you a question where I'm going to apply all things that I've talked about. Okay. So before writing, even though you are writing the final answer, when you want to round it off, before writing the rounded off answer, first give me that big figure. After giving the big figure, then you can round it off. Even God can accept it. For example, if you are writing the final answer maybe of the molarity, the final answer where the question is ending from, if you get like 0.01986 maybe this was supposed to be the molarity, a student can say this is approximately equal to 0.02 molar, because you will no longer use this value anywhere. The calculation has ended. But you find a student on the first procedure is rounding off everything, yet you will need to use that value in the second procedure. So you should avoid that. Now I'm asking, between number 3 of the exercise I left and number 4, which one should I do for you? Because I will just calculate one question. I know the moment you don't practice, they will keep confusing. And remember, this is redox titration. There is back titration and iodometry. Back titration gives the students headache, because for it, with back titration, we start calculating from the final stage going to the first stage. In other words, you interpret from the final stages, you calculate from the final stages going to the initial stages. But these ones are very direct. That's why the other one is called the back titration. You are going back. You are from the final to the initial. I will one time post you those questions of back titration, but I don't really know if we shall get time to go through. But you would need that limelight of back titration. Otherwise, you would need that light. So there was, I left you with 4 questions. We did it 2. I left you with the 4. So out of 4, I want to try either the 3rd or the 4th. The 3rd one, there was the one with the formulas. There was the one with the formulas. The one with the HAC2 of where they wanted you to find the values of A, B, and C. Then there was another one with the anoxalate. So I'm asking, which one should I do?
Teacher, do the one
when you
that
were trying them out, which one gave you the time?
the one that had a question of finding values of A, B, and C.
That is Katarina. Others, you are quiet. I don't know. Can I do that question and we go?
Yes, I think
Okay. Let me do that question. But to me, I think question 3 was hard because it needed you to combine 2 equations. But someone on question 3, you were supposed to get, is there anyone who got 78.5%? Question 3, as percentage purity of the ferrous oxalate. Is there anyone who got 78.5? If you didn't get this, you have to try until like Victoria dries.
for me, I got 78.
78 only.
Yes.
You must have rounded. Anyway, I will check your answers, Anna. I will check your answer. I check your answer. I saw your work. I will check through and mark it. But you should, or you must come up with this. Then for those ones who tried that number of ABC and getting the values of ABC, you were supposed to get the value of A as 2, the value of B as 1, and the value of C as 2. Did anyone get this?
Katonda.
Uganda is shifting the territories. So if you use the wrong average to do the number, you will lose the marks of the average and the mark of the final answer, but all your working inside will be marked correct. The moment you use wrong average and you use it correctly, everything will be marked, but the average, you lose those 2.5 marks. If at all you lie outside the accuracy. And the final value, of course, the final answer, if it is percentage purity, still you will not get the correct mark because you will have gotten a wrong answer. But everything there inside. So you can, if you get a wrong average and use it correctly on a procedure, you can miss like 3 marks. If on another procedure you also miss 3, you have missed 6 marks. If the number was marked out of 38, you'll get 32. Which is not bad. So, guys, you have decided that I do number what?
Number 3.
Number
Hey.
4.
Huh?
We go this one.
Huh?
Number 3.
And it is easy only that you people are very hard.
The number 4.
I'm just confused. But I think let me take my own decision on what to do because everyone wants me to do their number. You get? My screen has gotten poor sharing mode. No. Okay. Okay, what's wrong with that number 3? Okay, actually it was very, very, very technical. And that number 4 is just very easy. We cannot do everything tonight. Yeah, but in the time remaining, we can finish number 3. You are provided with the following. I don't have that first procedure. Give me the substances that we are provided.
You were provided with FA1, a solution that contains 4.60 grams of
4 point.
anhydrous. It is 4.60.
Is it 60 or 66?
66.
66.
You see, at least I remember my values. 4.66. Yes, grams of what?
Anhydrous sodium sulfite.
Anhydrous.
Anhydrous sodium sulfite per liter.
Per liter. So these are grams per liter, right? Then FA2
Then
is what?
FA2 is potassium manganate 7 solution. Then 2.0 sulfuric acid.
It is not FA3, it is just 2.0.
Yes.
Then
Solid D, which is impure ferrous oxalate.
One can call it ferrous ethane dioate.
Oh.
Ferrous oxalate. This is a very good question.
Then you are required to determine the molar concentration of potassium permanganate in FA2. Then percentage purity of the ferrous oxalate sample.
Okay, then I have from there. Now, members, yeah, you are lucky that they gave you the theory and they give you all the equations you need to know. How a manganate reacts with a sulfide, how a manganate reacts with iron, how a manganate reacts with oxalate, all are given there. So you're given how manganate reacts with the sulfite, with the oxalate, with the iron. You need to ask yourself, why are those equations given, all of them? It means that they don't want you to waste much time, meaning that the question is tight somewhere, not here on the equation. So sometimes the length of the question matters. If they give you many equations, just to know you have to take time interpreting. And that is what exactly happened in UNEB of 2019. I will send you that question and its values, and you calculate and see. It was a very, very, very tight question, because the compound was very hard for students. They looked at how the compound was written, all of them almost. So guys, you need to, I will give you the question and you try it out and see. 2019, even the one of last year, after collecting the question, I got the guide table. I'll give you also for last year, 2019 and 2020. They were all redox titration. No, they were all back titration apart from the one of last year. 2019, this was back. You may not manage it. It was back titration. Back titration is the commonest. So now they are giving us the theory. They have given us how a manganate reacts with all those. Procedure 1, members, just to know what takes you to the lab. If you don't know the aim, what takes you to the lab is to get 2 values, 2 volumes, the one of the pipette and the one of the average. It's the reason as to why you walk to the lab, to pick 2 values. The pipette value, you go to the lab to pick the pipette, and what? And the average value, nothing else. So they are telling us that we use a measuring cylinder, transfer 25 of FA1. Your teachers can need to be artistic. And one draws you those conical flasks, shows you how they have transferred what. But I prefer summarizing all the information so that I calculate as I look at what I've summarized. They've said that I transfer 25 cubic centimeter, that is procedure 1. Let me go to P1. 25 cubic centimeters of FA1, I transfer it to what? Into a conical flask. Then after reaching there, I add 10 cubic centimeters of 2 molar sulfuric acid. What is FA2 that I've transferred? It was FA1. The FA1 I transferred is a sulfite. Remember, this is a solution of a sulfite. So I've transferred a sulfite, okay? And I've added 10 of sulfuric acid. I'm titrating it against FA2. You are titrating it against FA2. What is FA2? FA2 is a manganate. This one real ideally should now tell you that you look at the equation. Among the equations they have given you, is there an equation of a sulfite and a manganate? Because you're having a sulfite being titrated against a manganate, meaning that the volume of the sulfite that reacted is 25. This is the one that is involved, 25. And the one of the manganate that has reacted is the average. I told you the aim is to get the tighter value or to get the volumes of the solution that have reacted, of which the one is either by the pipette or the cylinder, or the one is the average, the titrand. So what we are getting as the value, the average value from the table is the manganate, is the volume of the manganate that will have reacted, volume of FA2 used. Tighter values used according to that table. Which would be the tighter values? Which would be your specific tighter values used to calculate the average? Someone to tell me.
18.50. And yes, and 18.50.
Yes, when you're writing them, simply say 18.50, 18.50 cubic centimeters. If they have put for you the keyword, don't put it. That's the right, put commas. This one takes just a half a mark. Then average, calculate, don't say that they are the same. Therefore, even the average is the same. Who told you? Calculate and show us. And you pick your 2.5 marks. So meaning that the volume of manganate, do you all agree that it is also 18.50 because it is as a result of the average? So I have the volume of FA1 as 25 and I have the volume of FA2 as 18.5. If you're with me, type yes. Just to type so that we interpret procedure. The moment you interpret the procedure very well, there is nothing that fails on the question. You just need to be smart. Very good. Okay, now after interpreting this, let's go to procedure B, procedure 2. On procedure 2, weigh accuracy. That is why I told you that I don't know how your weighing scales are, but ideally we normally have the ones of 1 decimal place. So weigh accurately 1.4 gram of D. So you are weighing 1.4 grams of D, which is an oxalate. Add, after weighing it, add 100 cubic centimeters of sulfuric acid. I told you that when you add an acid and water, we don't account for those volumes. Okay? Because you are acidifying, right? Then start away to dissolve, transfer this one, you transfer it to a 250 volumetric flask, then add water up to the mark and label what you have gotten as FA3. You've weighed, added an acid, transferred to 250, filled with water, meaning you have prepared 250 cubic centimeter solution of FA3. So right now, as I talk, we are having a 250 cubic centimeter solution of FA what? FA3. Then Roman it is saying pipette out of FA3, pipette core, you remove 25, but me, I normally prefer my pipette values as 25, okay? Everywhere, I normally use 25. So pipette 25 cubic centimeters of FA3. So my FA3 that reacted is 25. Into the conical flask, take it to the conical flask. I don't want to draw. And heat up to 70 degrees Celsius. Now, as you heat, students wait for up to the temperature reaches 70. As you're heating it, if there is no congestion, you can be interpreting other parts of the question because you'll put a thermometer and you will see the temperatures either rising or falling, but they can't fall, they will be rising. But you can be interpreting other parts of the question. I will be calculating and whatnot. Then titrate the hot solution. After heating, this solution is hot. Titrate it against, or titrate it with FA2. Titrate it with FA2. But now you need to know what substances have been involved. I have pipetted 25 cubic centimeter solution. Remember, this solution you made is an oxalate solution, C2O4, 2 minus. It's an oxalate solution. And at the same time, there is iron. So it is an iron oxalate solution. So it means that FA3 has iron in it and it has oxalate in it. But you're titrating it against FA2, which is a manganate. So FA2 is a manganate, meaning that if this is the volume of FA3 that has reacted, then the average will give me the volume of a manganate that reacted. What is the essence of heating the solution? This is an oxalate. This is you want to ensure full reaction, because if you have not heated it, it means that the temperatures are not enough for the manganate to combine with that oxalate solution. there won't be complete reaction. So the titration, you may titrate, but you may not get any color change. So heating creates the suitable media for the complete reaction of a manganate with an oxalate. Okay, so the moment you see heating and you don't heat, just know, even if you call God on telephone, you will not get the answer. You will not get the accurate values. And God is good at denying someone who does things intentionally. God can deny you and you get wrong answers. Okay, so we are saying that if you pipeted 25 of Fa3, it means that the volume of Fa3 that reacted is 25, implying that the volume of another solution will be obtained from the average. And according to those values, we are going to pick 29.0, rather 22.90, 22.90, regardless of where they are located. Because I've picked from the first one and from the last one. So since they are the same values, then they will give me the average titer value as 22.90, and that is the value that I will take as my average. If I'm clear with you on interpreting both procedures, type yes and we start stressing with questions. Because now we are going for questions. But if I'm clear with interpreting with you the facts, say yes, 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 yes. I see many yeses. Okay, those ones who have not typed the yeses, these are actually things. It is okay, provided you understand. And those ones who are failing, if you mute intentionally, God is watching you, no problem. But I will remove you. Okay, so you may not understand it very excellently well from me, but you can go back yourself and maybe try to pound it on top and you see. Looking at part of the question, they want you to calculate the molarity of potassium manganate in Fa2. Molarity of potassium manganate 7 in Fa2. But in brackets, they have made it clear and gave you the atomic masses of sodium, sulfur, and oxygen. And initially, you have the mass of a sulfite, meaning go first get the moles. First get the moles of sodium sulfite, because the a sulfite reacted with the manganate, meaning that a sulfite reacting with the manganate, if I get moles of a sulfite, I can get moles of a manganate, and then it's molarity then. I guess I'm clear. So here, get moles, get molar mass of sodium sulfite. I told you have to show all the steps. Sodium 23 times 2 plus sulfur 32 plus oxygen 16 times 3. 48 plus 32, that is 80, plus 36, 126. You get 126 grams as the molar mass of sodium sulfite. After getting the moles of the molar mass of the sulfite, then get the moles. With mass, you can get moles. When you say molar mass, this is the mass of 1 mole. So come and tell me that 126 grams of sodium sulfite, before you made it a solution, sodium sulfite contain 1 mole. Contain 1 mole. What about 4.66 grams? 4.66 grams of sodium sulfite contain 1 times 4.66 out of 126 moles. How many moles do you get? When you divide this, because I 4.66, 126, 0.037. Am I allowed to call it molarity? Yes, because I'm converting grams per liter. Meaning when you convert grams per liter, you must get moles per liter, which is molar. So don't ask me why I have put capital M. I'm converting from moles, from grams per liter then the moles I should get should be moles per liter, meaning that these moles are in 1,000. Okay, but the reacted volume of a sulfite is 25. So because it reacted with the manganate, you must get the moles in a reacted volume. So you will be telling me that 1,000 cubic centimeters of Fa1 contain 0.037 moles of sulfite ions. Now we are talking in a solution. What about 25 cubic centimeters of Fa1 contain 0.037 times 25 out of 1,000 moles? Here I'm getting the reacted moles. So the moles that reacted will be, I can record my answer in the exponents, 9.25 exponent -4 moles. Avoid the mistakes even. Sometimes we prefer this. That is a student. Remember, this one that you've done here is one mark. These are all marks, Munang. You just write every step. Now, after getting moles of a sulfite, I can easily get moles of the manganate because they freely gave me the equation of the sulfite and the manganate. My equation is 1 on the theory. If they had not given it to you, you have to write it because you should know how a sulfite is a reducing agent that is oxidized to a sulfate, and how a manganate is an oxidizing agent that is reduced to manganese to ions and water. If it is not written for you, it's not mandatory that in every paper they'll be writing for you the equations. Not really. So by checking on that one first equation, 5 moles of a sulfite react with 2 moles of a manganate, meaning that if I need moles of a manganate, however, show me the steps. Tell me that 5 moles of a sulfite react with 2 moles of manganate ion. What about these moles? So moles of a manganate will be equaling to 2/5 times 9.25 times 10 to the power -4. I've used the equation. So the moles of the manganate we are going to go with are, what are the moles of the manganate? After dividing, you'll get 3.7 exponent -4 moles. These are moles of the manganate. After getting moles of the manganate, the question is the molarity. Now you've got moles of the manganate, meaning that these moles are in the reacted volume, which is 18.50. So tell me that 18.50 cubic centimeters of Fa2 contain these moles of manganate ions. What about 1,000? You will have gotten for me the molarity of the manganate. I'm going to go to a different page where I'm going to wrap this. So you should have summarized these things so that when you see me applying them on the other steps, you don't ask yourself where I'm getting these volumes. Okay. So on my next page, how many marks does the equation take? It all depends, but in most of the cases, 1.5 marks if you write it by yourself. But if you photocopy what is written there, no mark, because it is already written by you, or rather by the examiner, by the setter. Okay. So when the UNEB gives you an equation, don't expect any mark on that. But you can apply the equation to get marks of your own calculation. Rina?
Yes, excuse me, sir. Would it be right for, okay, on that part of finding, considering that part of finding the number of moles in 4.66 grams, would it be right to, instead of writing the entire sentence, to write, let's say, 4 moles in 4.5 grams of sodium?
No. Use first principles. And these are the first principles. Don't be lazy. Just write the whole thing, you get all marks. Okay. I know your teachers, you have different teachers. Your teachers will tell you other things. Don't be like, but Hyper told us this. I met a teacher in the holiday told me this. No, me, I'm telling you what I think is original. Your teacher will tell you what he thinks is original. Pick what you think is very original. But don't choose people you met over the holidays. Yes, Rachel.
Yeah.
Your network is very poor. I can't get you well. Your network is very poor. Your network is very poor. Let me first answer this person. So what if someone is saying, so what if they hadn't put grams per liter? They will give you the mass. They can say this is 4.66 grams, maybe we are dissolved in 500 cubic centimeters. Meaning that you will first convert them to grams per liter to 1,000, then you continue. You would say 500 contain this mass. What about 1,000? Get grams per liter, then continue like the way we are doing. Someone is, oh, okay. Rachel, your network is not good. And let's save time, members. Let's save time. After getting these moles, I'm wrapping this thing. Hope you have captured all the information. Then we are saying that to get the molality, these moles we've gotten are in this volume. If you have a question, you can type it. Then what about 1,000? So simply come and tell me that 18.50 cubic centimeters of Fa2 contain, we need these values, we need these words, 3.7 times 10 power negative 4, because the reason that's why we need these things, we are looking at someone who is going to become a doctor, who is not going to be lazy after being called for by a patient. The patient is in a critical condition. We need someone who can rush. So you should be, that's why doctors write badly. You are rushing, you don't have time to waste. Out of 18.5. We need an engineer who will carry something in case of emergency, maybe bridge is breaking. So every student who got 0.02 molar here was right. If you got it, you are right. If you got it wrongly, you are wrong. Can I be denied marks when I use chemical symbols rather than writing in words? Which chemical symbols? Which chemical symbols? Here I forgot of manganate. Which chemical symbols? Because I'm writing chemical symbols. Members, don't ask me anything about writing words. I made it clear when I was briefing you that you must write in first principles to get all the marks. If you feel like you need, you choose between the two, getting many marks and a few marks. If you need a few marks, use the formulas. If you need all marks, use the first principles, period. Don't ask me anything more about that. That's why I first gave you the guidance. That's why I first gave you the guidance. Perhaps I leave the moles at 0.0000036 without rounding off. You go to heaven very well, no problem. I'm sorry for being somehow stubborn, but the moment I tell you something, just to know, maybe I don't need a question on that. If especially I use it as a first fundamental thing. I first told you how we mark these things, how we should present work. Strictly the first principles, if you are interested in all the marks. But if you feel like a 40 out of 80 can work for you, use formulas. No problem. So your presentation has to be pregnant. This is this is the morality that we've got. This is the morality that we've gotten. Hope I'm clear. Members, if I'm clear with that first part of getting the morality, just type yes. If you're clear with the morality, how I drove up to the morality, don't forget that these are 3 things you have to stand for yourself. So if you're clear with how I've gotten the morality, good. I want us to do the other remaining parts chap because I want to communicate to God about tomorrow. So let's go ahead and see Now, part two is saying what? Call me at 10:20. I'm sorry, guys. We are saying what? Where are we? We're on part two. Part two needs the moles of manganate. Part two needs moles of manganate. You have to be very careful with these statements that reacted with 25 cubic centimeters or 20 cubic centimeters of Fa3. Meaning now, since Fa3 was prepared in the second procedure, you have to go in the second procedure. But I need moles that of manganate that reacted with Fa3. Remember, Fa3 was iron oxalate solution that you prepared, and the moles of permanganate they want. It means they need moles in the reactive volume of permanganate in Fa3. Now, who can tell me the volume of Fa2 that we shall use? Who can tell me the moles of manganate that we, rather the volume of permanganate that we shall use? Which volume reacted with Fa3 according to our summary? This was Fa2. Now this is Fa3. So which volume reacted with the permanganate according to our summary? Very good, Patricia. 22.90. Very excellent. Meaning, if we are to get the volume that reacted with the Fa3, we shall say 1,000 cubic centimeters of Fa2 contain the molarity we've just gotten, 0.02 moles of manganate iron. What about 22.90 cubic centimeters? But members, muting has no problem. When you mute, I've removed someone because of the noise. So 22.9 will be containing 0.02 times 22.90 divided by 1,000. This one will give me the moles of manganate that the moles of manganate in Fa2 that reacted with Fa3, and that one, members, should give you 4.58 times 10 to the power -4 moles of manganate. So the moles of permanganate iron that reacted with Fa3 is this. If you agree with me, type yes, and I take you to Roman 3, which was the determining factor. Roman 3 was the determining factor. So if you've understood up to this part 2, type yes, and we see. Yeah, the others don't type, but it is okay. It is okay. Okay, now from here, let's all march to Roman 3. Someone who failed Roman 3 could not pass anything. Now, Roman 3 is saying, calculate moles of iron 2 ions. They need moles of iron 2 ions in 25 cubic centimeters, or depending on the pipette used, but for us we use 25 of Fa3. Now, remember in the previous part, okay? In the previous part, I've gotten the moles. In the previous part, I've gotten the moles of manganate that reacted with Fa3. But remember, Fa3 has iron 2 ions, and they need moles of iron 2 ions. But you want to eliminate the oxalate. Because at the end of it all, they need a percentage purity of the ferrous oxalate. So we have iron 2 there, and we have the oxalate. We also have the oxalate iron in Fa3, implying that if they say moles of iron 2 ions that reacted with the Fa3, it means that we need to write a combined equation of a manganate, because we've already gotten moles of a manganate from above, 4.58 exponent -4. So we need to get a combined equation of a manganate reacting with iron 2 and reacting with the oxalate. That is it. Then there we can get moles of iron 2. But when an oxalate is also involved, so those equations which they gave us 2 manganate. Is it 2 manganate plus 6 hydrogen ions plus, anyway, I'm sorry, I will not be including state symbols. 5 sulfate plus 2 manganese plus 3 water. This number came in 1994. Manganate plus 8 hydrogen ions plus 5 iron 2 ions, giving us manganese plus 4 water molecules and 5 and 2 and 3 ions, because it will be oxidized. Then we have 2 manganate plus 16 hydrogens reacting with 5 oxalate ions to give us 2 manganese ions plus 8 molecules of water and 10 carbon dioxide. But they need iron in 25 cubic centimeters that did what? Yes, they need moles of iron in Fa3. But remember, we've got any moles of manganate that reacted with Fa3. But you cannot rule out an oxalate and you tell me that you are going to consider this equation, then what would be the essence of this? So here a student had to combine 2 equations of the reaction between manganate and both iron and oxalate. That is what the trick was. You have to give me an equation of manganese reacting with oxalate and iron. Now we already have the one with iron, so we just have to add the one of manganate. As simple as that. So we shall combine. Okay, we are going to combine 2 equations of reaction we are going to combine 2 equations of reaction between manganate and both iron 2 and oxalate. So you already have this. So manganate and manganate, they form 3 manganates. Aqueous. That equation now is the one that carried the max 2 and 1.5 plus hydrogens. When we add them, they'll become 24 hydrogen ions. Plus we have 5 iron 2 ions aqueous plus 5 oxalate ions. C2O4 aqueous, giving us 3 manganese ions, manganese 2 ions, plus how many molecules of water? 12 molecules of water. and then 5 iron, 3 ions, and finally 10 carbon dioxide molecules. So that is the equation that now you can use. You don't eliminate anything. You just eliminate this equation of a sulfite because this was for procedure 1, which we got done with. So we no longer need this. We just need the equation where a manganate, now you can't eliminate, but we are combining. Combining, you add. So there will be 3 manganetes, 24, you write everything. Now, since we already have moles of manganate, now we can get moles of iron 2 ions. 3 moles of a manganate, 3 moles of manganate ion react with 5 moles of iron 2 ions. What about these ones that you've gotten? So 4.58 times 10 power negative 4 will react with 5/3 of 4.58 times 10 to the power negative 4 moles of iron 2 ions, and this is going to give you moles of iron 2 ions as 7.63 times 10 to the power negative 4 moles. And these moles, because of these moles being for iron 2 ions, then they are moles of the oxalate. Okay, these are moles of iron 2 oxalate solution. If you're with me, type yes. There you had to combine the 2 equations. So if you're with me on all that I've done, yes is enough for me. We are chasing time. That part, the last part is very easy. The last part is very, very, very easy. Okay. Okay, the last part, they are saying determine mass of ferrous oxalate in 250. To get mass of ferrous oxalate, first get moles. Now that mass that those moles that we've gotten are the ones that reacted. Remember, so we have gotten 7.63 times 10 to the power negative 4 moles of iron 2 ions. But this one was a solution of Fa3, which Fa3 was 250. Fa3 was 250. But being this one being the reacted moles, it means they are in the reacted volume, which is 25 that we pipeted. Okay, so you'll be saying that 25 cubic centimeters of Fa3 contain these moles of iron 2 oxalate. What about 250? That is when you'll get the moles in 250. Patience to combine the equations, add them. Just add them. Add the equation of manganate reacting with iron and with oxalate. Add them. Contents of the same side, add them. The ones which can't be added, write them the way they are. Okay. So you'll be saying that 25 cubic centimeters of Fa3 contain the moles you've gotten 7.63 times 10 power negative 4 moles of iron 2 oxalate. First get moles of an oxalate in 250 because that is what they want. Actually, they want the mass in 250. Okay. So 250 will be containing, write all the words, 7.63 exponent negative 4 times 250 out of 25 moles. So this one will give you moles as 7.63 times 10 to the power negative 3 moles. These are moles of iron 2 oxalate in 250 cubic centimeters, but they need the mass. They need the they need the mass. They need the mass. Now, to get the mass, you have to look for the molar mass first. You have to look for the molar mass first, and that molar mass, the molar mass will give you the answer very well. So get molar mass of iron 2 oxalate. Iron is 56, carbon is 12 times 2, oxygen is 16 times 4. 64 plus 24 plus 56 will turn up with 144 grams. Come and tell me that 1 mole of iron 2 oxalate weighs, 1 mole of iron 2 oxalate weighs 144 grams. What about these moles? So moles in 250, 6.63 exponent negative 3 weighs 144 times 7.63 exponent negative 3. So it will give you the mass in 250 as 1.099 grams. That is what you get. If you're with me there, on the mass in 250, type yes, and I show you how we get the percentage purity, and we call it a night. If you're with me, when I've gotten the moles in 250, mass, what, everything. Yes, now after getting that, members, 1 point, is it 0.98? Eh? Okay, Kale, whatever, I think maybe I miss, I don't know, but I have 1.099. Now, after that, they want the percentage purity. They want the percentage purity. How do we get the percentage purity? To get the percentage purity, if people have funny questions. How do you find the proportion of iron to ions in the oxalate? Iron 2 is constituting to an oxalate. So by getting the moles of iron 2 ions, I've gotten the moles of an oxalate. All right? Only that all these ions are important in the oxalate. That's why we wrote the other equation. Okay? Now, members, after getting this, we can get percentage purity very, very, very easily. Very, very easily. How do we get percentage purity? How do we get percentage purity of the oxalate? Percentage purity will be equaling to mass of ferrous oxalate that you've gotten over total mass of the impure sample times 100. So what is the mass of the oxalate? What you've gotten, 1.099 out of what is the total mass of the impure sample of the oxalate, members?
$1.4.
1.4. Students made a mistake by using 4.66 of a sulfite, yet we weighed 1.4 of D, which was a ferrous. So 1.4 times 100. How do you know that you have failed? If you find that the mass you have here is greater than the impure. Someone would have 1.5 of 1.4 times 100, and you find someone with 115%, and also give you less than max percent. So this person was supposed to get the percentage purity as 78.5. I can't go beyond this. Just wish you God's blessings and yeah, to keep praying for you guys as you pursue your academic careers. Can I wish you all the best tonight? We cannot go beyond this. It is already 10.
Thank you, sir.
You're welcome, praise. Thank you all for attending. Yeah, whenever you always get time, never know. Because I have a feeling that you should go back to school when you know back titration. Filling a table has no problem. Everyone can fill a table, but not everyone can just start calculating. You need to practice calculations. That's why I saw it wise to engage you. That's why I saw it wise to engage you. I wish you all the best, guys. The mighty
Thanks,
God
teacher.
bless you. My voice is low because I'm kind of tired. I had a busy schedule, but nevertheless, good time.